Hello everyone. Welcome to this lesson where we are going to learn about blockchain in a nutshell. This is going to be a quick introduction to blockchain and its concepts, but you are going to learn whatever you need for the rest of this course. Let's start with understanding centralization so that we can understand decentralization. Now, let's say this is your phone and you are using Instagram on your phone. These are the posts, people's comments, people liked it. And it goes on. What happens when I try to, let's say, upload a new image? First, this goes and connects to the closest Facebook server. Let's say this is the closest Meta server. And here is our server. We send requests, we send information that we want to upload photos. And then this closest Meta server to us do the job for us. And then it gives back the response, which is the new page with our image uploaded. So here business logic happens. And here we use it. We get the response, which is the new page with our image. This is centralization because, as you can see, we depend on Meta server in this example. If something happens to Meta server, Meta as a company, then we cannot use this product. And that's the definition of centralization. There is a central authority. How it is different with decentralization? Let's call this decentralization. In the decentralized version, here I'm the user. I got my phone or PC, whatever we got. We want to connect to internet. This time, once connect to internet, we don't connect to the closest server from any company. Instead, we have lots of servers. I'm going to draw a couple of them, but for big blockchains, there can be thousands or millions. We call them nodes in general. We call them blockchain nodes, but they are basically servers that we used in our previous example. Whatever happens is that we try to connect to these servers. We connect one of them, let's say we connected this one. This does the job for us, and then we get the response. So what's different is here is that we got a lot of servers or a lot of nodes. In the previous example, we just had one of them, which was Meta. Here, these nodes are independent. So if something happens to this one, I can use the second one or another node. What's happening here is that these nodes, these servers, all have the same information. So whichever we use doesn't matter. We use one of it, then we get the response back. This is decentralization. You can think this more as a democracy if the previous one was more like a monarchy. We said that we choose one of the computers to do the job. Let's say this is our blockchain, and we are using this blockchain as a group. So this is our blockchain. And we are using this blockchain, not a single server, but we said that one of them do the job. But how we decide which one is going to do the job? There are two ways. The first one, we call it proof of work. And the second one, we call it proof of stake. There's actually much more options than proof of work and proof of stake, but we mainly use proof of work or proof of stake. So proof of work is used by Bitcoin, and proof of stake is used by the rest of the major blockchains, but we can say Ethereum, which is the main blockchain that uses proof of stake. Whatever happens is that, let's say I got my servers. Let me draw this back. Let me delete this. So I got my servers here, and job comes to my blockchain, a request. This can be anything. Something is going to happen on the blockchain, and one of the machine is gonna do it. In the proof of work, let's first talk about proof of work. These machines try to solve a puzzle. So we say they try to solve a puzzle, but what they are actually doing is that they are actually just trying to guess a random number. Whichever guesses the first or solves the puzzle first, let's say this one did, then this do the job. Why would they try to do the job? Because these machines are not from any company. They don't belong to Bitcoin LLC or something like that. These are the individuals that are actually maintaining these servers, these nodes, for us to take advantage. The motivation behind Facebook or Meta when they do this, because they are also providing the service for free. They are collecting our data, they are selling the data so that they can make the profit through our data. So that's their business model. But in this scenario, we are not giving them any information that they can use to identify us, so data is not usable. So why would they actually try to put a lot of money to build up this server, give a lot of money to maintain it for the electricity and everything? The reason is the gas fee. So we are actually sending some gas fee here. We say this gas fee because it's more like a literal gas fee. If you want your car to go, you need to pay some money for the gas. The idea comes from there. What happens is that we are actually giving a little amount of token to this one of the, let's say, nodes or servers, so they can do our job, and in return they can get this gas fee. Instead of paying with our data, we are actually paying with tokens here. And they have the motivation because for their work, for their hard work, let's say, they can have this gas fee. And that's called proof of work, because they are proving that they work for our tokens. Even though this is nice, it has some hiccups. So first of all, it's not very efficient. A lot of machines are working, a lot of computing power, a lot of energy going wasted because just one of them is going to get the job. So this is not very energy efficient, and this is not very fast. So that's why the transactions on Bitcoin is not that fast. Because of these two main problems, we came up with an idea which we call proof of stake. Now let's talk about this proof of stake. With the proof of stake, what we have is we are actually staking some tokens on each of these servers or nodes, and in this case we are going to call them validators, but we are all talking about the same machine, the same idea. Let's say this has this amount 2, this has like 3, this has 1, and this is also 1. What happens is that we are actually staked some tokens. Again, this user, let's call this Simon, with a little bit longer hair. He wants to do some job on the blockchain. He sends some requests with some gas fee. And again, we choose one of these machines to do the job. But the way we choose these machines, they differ. So that's the difference that we are talking about. So instead of machines working really hard to get tokens, what we have is we are actually giving this execution right randomly. So it's not total random, because based on how much token they got staked on their validator, the more chances they have. Let's say this is A, this is B, this is C, and this is D. So B has more chance because it has more tokens staked on it. A has less chance than B, but more chance than C and D. C and D have equal chance when they compare to A and B. So whatever happening is that we are not actually wasting a lot of energy, because how much token we have, how much chance we got, then it's just given randomly based on these chances. Again, that is not totally random, but there's a 50% chance in a heads and tails, but it's rarely 50% chance once we flip it. So that's why we say random. So in this case, we are going to give it randomly, and one of the validator is going to get the gas fee. And since we staked tokens in this validator, then they are going to split the gas fee to us, to the user who staked the tokens. And this is called proof of stake, which is much faster because they don't try to solve a puzzle. We don't need to waste time there, which is much more energy efficient, because a lot of thousands or millions of machines doesn't have to work endlessly to get the number that they need to solve the puzzle. That's proof of work and proof of stake in a nutshell. Now let's talk about another concept which is also very important, which are the smart contracts. Again, we are going to have, let's say, smart contracts here. We are going to have Bitcoin example and Ethereum example. Bitcoin, which was the starter of all things, it was all great, but it didn't do much. It was more like a ledger where we knew which address had how much tokens, and then we would say, okay, so this is me. Let's say this is Simon, that you can understand from the half long here. This is Simon. Let's say this is Jessica. who has much longer hair, and Simon has like 10 Bitcoin, Jessica has 5 Bitcoin, and we forgot the bit. Then Simon sends, let's say, 3 Bitcoin to Jessica. What is happening on the blockchain, which is Bitcoin, is that we have a ledger saying Simon 10 Bitcoin, let's say, Jessica 5 Bitcoin, and I'm overly simplifying this so that it's easier to understand, but the concept stays the same. Then we have someone else, we got like Amy, Bob, and it goes like this. So once I send Bitcoin, I'm not actually sending anything. I'm just updating the data on the blockchain. Once I send 3 Bitcoin, what's happening is that the machine that got the job actually says now Simon has 7 and Jessica has 8. So I just changed the data. There's nothing that I can send. I'm just changing the data, but we say sending Bitcoin, which is much easier for us to communicate with this language. Now Simon has 7 Bitcoin and Jessica has 8 Bitcoin. We updated the data, and that's how Bitcoin is working. But we needed some better concept because we gave you the example of the meta server with the Instagram. Instagram was doing much more than just updating some data. Meta server knows what to do because Meta owns Instagram and they know the code, and so once I want to do something on the Instagram, Meta server does the job for me and gives back the page so that I can view it. Ethereum came up with a concept which is called smart contracts. It's called contracts because they're actually like contracts. We define what is going to happen once a particular function is called by an address. We define the terms of the contract. We just upload it on the blockchain. So again, let's say this is, I don't need to call the name, I guess. This is Simon. We understand from here. And this is, let's say, Ethereum in this example. And we got much more machine. And I have a decentralized application. So decentralized application means that application that has blockchain on their backend. So in general, we would have like normal backends that we actually store on a centralized server. People can use like Amazon Web Services, Microsoft Azure, or Google Cloud, or any other service, or maybe you have your own, but it's still centralized. It's still you or some other company is maintaining it. But in this scenario, no one is maintaining it. It's just maintained by the blockchain, by the algorithms. So what's happening is that I got the code of this smart contract. Every node on the blockchain has this smart contract. Again, I send my request. I'm trying to log in somewhere, let's say, or I'm trying to upload an image on a decentralized application. Then this one of the machine, again, we choose, let's say, the first machine. Until here, everything is same, but then the smart contract is going to be executed because we are saying I'm sending gas fee also with my transaction, and this is called transaction. I'm going to do something on the blockchain, and we call this transaction, which has a couple of data like the gas fee and also the data was what I want to do with this transaction. And also in this scenario, we got the data which smart contract that I'm going to communicate with. So the address of the smart contract, let's say gas fee to this address, and let's say we got the address here. We know which smart contract, and again, every machine has the same data including the smart contracts, and then my code is executed based on this smart contract code, and I get my job done like the meta server did it for me. But here every machine has the same smart contract, and you can also think smart contracts as programs that are on the blockchain. A small program that is on the blockchain, we call this smart contract. Again, the contract name came because we generally say, okay, if this function is called, that is going to happen. If this function is called, that is going to happen. So we just define the terms of this contract, of this program, and that's why we call this contract in the first place. But if the name is confusing, you can think this as a program. Now, let's talk about another concept which talked a lot by people, and which are the tokens. Let's say token here. we learned that there is nothing tangible actually we can send. So what we do is we update the data. But what are tokens? So tokens are actually smart contracts. So in the smart contract, let's say I have some code, and this is my smart contract code. In some place I have, let's say, total supply. And let's say I say 10 million. And this is the total supply of my token. And then let's say I have a map. And in this map, I say Simon got 5, Jesse got 6, let's say Walter got 1200, and so on. This is actually what token is. And once I try to update it, what happens is that, again, I send Walter one more because Walter needs more token, apparently. Let's say there's a transfer function. Let's say this is a function, and the name is transfer, and it has the data in it. And once this function is called, this map is going to be updated. Simon will have 4, and Walter will have 1201. So this is the idea of the token. The tokens are actually smart contracts. We hold the data, and then once we say, okay, we want to transfer some tokens, then we are updating the data on the smart contract. Let's look at the concept of wallets. You will see wallets in a little bit more detail in the next lessons. So wallets are just programs that are working with the smart contract so they can display it. So this is, let's say, smart contract A. There's another smart contract that's called B, and let's call this C. So these are all different smart contracts, but they are tokens working with a wallet. And this wallet is a program that is showing the given address. Let's say we have the address here, how much token it has on A, B, and C. Let's say I have 12 token A, 5 token B, and 4 token C. And wallet is just a place to show me these tokens by sending some query calls to smart contracts. And then if I want to transfer something, I can use my wallet, which also calls the function from the smart contract. So everything is happening on the smart contract. The tokens are smart contracts. The wallets are communicating with smart contracts to show us how much token we have. And once we click on the buttons, they are just sending some transaction to the blockchain from our address. We can actually use this smart contracts, so we can actually send some tokens and work tokens, let's say. And this is the basic idea of the wallets. We are going to talk about more on this subject, and of course, we are going to have a lot of hands-on experience working with these topics. This is all for this video. Thank you very much, and hopefully see you on the next one.